Hello and welcome to today's RIMS webinar sponsored by TÜV Global Risk Consultants. Reduce your risk of electrical fires. I am Justin Smolison, Business Content Manager here at RIMS, the Risk and Insurance Management Society. A few notes before we begin. If you have a question for the presenters during today's session, please submit them by writing in the question box. Feel free to ask at any point during the presentation. We will reserve time at the end for Q&A. Following this session, the recording will be available through the on-demand events page of rims.org, and all downloads and contact information will be accessible to the sponsor. And on with today's presentation, leaders from TÜV Global Risk Consultants will discuss how electrical hazards lead to property damage, business interruption, and worker injuries, mitigating electrical risks, and getting compliant with NFPA 70 standards is essential. This webinar will explain hidden fire risks that may be lurking in your electrical systems, and those can lead to short circuits, arc flashes, or other dangers. RIMS is thrilled to welcome a global audience, and now I will hand it off to our moderator, Jared Shelley.
As Justin said, my name is Jared Shelley. I'm Demand Generation and Content Marketing Manager for TÜV Global Risk Consultants. Today, I will be interviewing two experts. Stephen Wilder is Senior Consultant for Arc Flash for TÜV Global Risk Consultants. Stephen is an expert in industrial risks, fire safety, and has helped countless companies reduce their risks of arc flash accidents and electrical fires. We'll also be talking with Jeff Freilich, Global Manager of Infrared at TÜV Global Risk Consultants. Jeff has more than 30 years of experience in risk engineering and specializes in infrared thermography, fire protection engineering, and electrical systems. Electrical distribution and equipment are the leading causes of fires in industrial properties, according to the National Fire Protection Association. In fact, they account for 1/4 of all industrial fires. In today's webinar, we will discuss dangers associated with electrical hazards, costs of letting electrical safety issues linger, simple ways to minimize electrical fire risks, and mandatory versus recommended electrical safety measures. One quick note, we will conduct this webinar interview style with me asking questions of our panelists and then providing answers. If you have a question of your own, please put it in the Q&A box on your screen and we will answer it after our presentation. So let's get started. This one's for Stephen. What are some dangers that can happen when electrical systems experience short circuits, arc flashes, or other malfunctions?
Well, thanks for having me here, Jared. There are 3 studies that we typically do in one report. It's a short circuit, a coordination, and an arc flash study. The short circuits can cause fires, heat, pressure, personal injury. Coordination failures generally don't cause fires or personal injuries, but they can cause significant downtime. Arc flashes can cause significant property damage and personal injury. An arc flash is typically the temperature is around 35,000 degrees Fahrenheit, and a 50,000 amp arc can throw, it provides 1,700 pounds of force, so it can easily throw a grown man across the room. Such pressure could also cause bodily injury, not just from throwing the person, but it's also likely to destroy their eardrums. And shrapnel from the switchgear that explodes can also be shot into the person. And that's just the pressure we're talking about. The heat, of course, is a greater threat. At 35,000 degrees, third-degree burns are very likely, depending on how close you are to the source.
Absolutely. That's hotter than the surface of the sun. Is that right, Stephen?
Yes, yes, it is.
So next question, what are the costs associated with electrical safety gone wrong?
Well, in addition to this, I also have a few years of forensic engineering experience, particularly investigating electrical fires. Unfortunately, they're more common than you probably think. The damage to property can grow very quickly. It's not just the fire damage, but there's also smoke damage, water damage from the sprinklers, and of course, there's downtime. It only takes a small fire to rack up a very large bill. And of course, there's really no fair way to reimburse for fatalities or serious injuries. It's a tragedy that makes everyone regretful, and there can be a significant loss in employee morale. Sometimes key people could leave the workplace even though there's no event, just if they feel that the company isn't properly protecting them.
And then, without naming specific companies, can you provide an example or two of electrical problems that led to fires at major facilities or other buildings?
Yeah, well, I live in the New York area. Just a few months ago, there was a very large fire in a Bronx apartment building that killed 19 people, including 9 children, due to the arcing of an electric heater. There's a distribution center from me not too far that had about $9 million worth of damage a few years ago due to an arc. There are many smaller ones that I've seen in the forensic business. I'd say there are probably 50 electrical forensic engineers in the New York City area working full-time on electrical fires. Many of them are due to arc flashes. Personal injuries aren't really discussed much because people don't like to hear of them, but I've met a number of electricians and unfortunately ex-electricians who've been exposed to an arc flash and their lives have changed considerably. It's a morbid topic, and I understand most people don't really want to hear about it, but it does exist, and it is a tragedy.
And Jeff, what about you? Do you have any examples?
Yeah, absolutely. In my 34 years, we've seen countless incidents of switchgear, switches, breakers, disconnects, you name it, critical equipment and assets failing, from a switchgear that hasn't been properly maintained, potentially bus ducts that are accumulated with dirt and debris, contaminants, moisture, all kinds of different elements, environmental factors, corrosivity that will cause electrical or mechanical systems to fail. And as Steve mentioned, the failure points are catastrophic with consequences relating to both physical damage to the assets, surrounding collateral damage to the components around that, dangers to workers and maintenance people, as well as interruption and long lead times. So the costs are compounded X-fold.
Absolutely.
Yeah. I'm sorry, Jared, can I just jump in?
Yeah,
I just want to clarify my role and Jeff's role. Jeff's team prevents the arcs from happening through his infrared group. My team provides the PPE requirements for workers to protect them from an arc. So if you don't take if you don't use his services, you have to take my recommendations much more seriously.
We appreciate that two departments work in collaboration because we both depend upon each other, and our clients and the world out there depends on it as well.
Absolutely. So thanks, guys. Now that we know the risks, let's talk a little bit about the standards and what's mandatory versus what's like really highly recommended. So let's start with the mandatory, Stephen. What are the mandatory actions to keep a facility compliant with standards from OSHA and NFPA?
Yeah, this is somewhat controversial. The NEC requires a label that the National Electrical Code requires a label that warns workers that an arc flash hazard exists on the electrical equipment. It doesn't require an assessment of the risk or instruct the worker what to do about it. That's all laid out in NFPA 70E. But OSHA doesn't require a specific arc flash label compliance with 70E. OSHA requires employers to have a safe work environment. But if an arc does occur and the company doesn't have arc flash labels and someone gets injured, the plaintiff's attorney is likely to argue that the company didn't provide a safe work environment because they didn't comply with codes that are so well known and so well used to anyone knowledgeable of industrial safety. So I would argue that the labels have a de facto mandate. It's also possible that an OSHA audit could result in a citation for not having an arc flash label, that the workplace was unsafe. An argument could be made that OSHA doesn't mandate arc flash labels in accordance with 70E, but that argument would have to be made and won, which could be fairly time consuming and costly, and in my opinion would be unlikely to be successful.
They can do that under the general duty clause, so there's all kinds of ways that can happen.
And then, so Stephen, can you provide a brief review of the recommended but not mandatory standards like NFPA 70B?
Well, NFPA 70B recommends the best practices for electrical equipment maintenance. It provides, among other things, recommended scheduling to upgrade the short circuit coordination and arc flash studies. These are not meant for personnel protection, but for protection of property. It's mostly maintenance. It's maintenance related. It's not for personal protection.
Yes, NFPA 70B, unfortunately, with the backdrop doesn't show, but it is a very illustrious and lengthy document. You can go to Annex L, which is the maintenance intervals. It'll provide you with an initial guideline for inspecting, testing, and maintenance of your electrical equipment. It'll break it down into specific items, components, tasks, functions, frequency intervals of inspection. And this could range from things like bus and cable, and based on the voltage and the type, switchgear, relays, battery, rotating machinery, generators, AC or DC motors, transformers. There's a whole host of assets that need to be checked, inspected, tested by qualified professionals. So interestingly, on the infrared side of the equation, if you go into Chapter 11, Section 11.17.5 will give you the inspection frequency and procedures. And in there, it states annual frequency for infrared inspections, or more frequently based on a variety of different potential anomalies, loss experience, installation of a new equipment, other environmental changes, operational conditions, load conditions. So you might end up doing it as frequent as monthly, quarterly, semi-annual. So it's a great standard, and there are others as well, but it's definitely one of the leading ones, if not the most important in North America.
So I guess if I'm hearing this correctly, NFPA 70E is mandatory, you have to do it. NFPA 70B is highly recommended for optimal equipment reliability.
Yes, that is correct.
Great. Let's move on to a short circuit study. Stephen, what is a short circuit study?
Okay, well, sorry if this is remedial, but I'm trying to put this in layman's terms. But a short circuit occurs when two energized wires, those connected to a voltage source, such as a generator or a battery or a utility, touch each other without anything between them. Sometimes this is by accident during construction or testing or maintenance, and sometimes it's due to an equipment failure. The voltage source creates electric energy. If it's not connected to anything, the energy just stays in the source. But if there's something connected to it, the energy is transferred to the object. But if there's nothing connected to the source other than the wire, when those two wires touched, all the energy is just transferred into the wire. And in general, wires aren't sized to withstand this. And so there's too much energy being transferred into the wire, so it catches fire. Now, if the electrical system is designed properly, there's a circuit breaker upstream of each cable that's designed to trip the circuit or open the circuit before that energy is transferred into the wires. But that's not really what a short circuit is about, technically. I mean, each breaker has two ratings. There's a trip rating and an interrupt rating. The trip rating is what we normally refer to when we talk about circuit breakers. When we talk about a 20 amp breaker, that means if you put more than 20 amps on it, the breaker will trip. Most people get that, they understand. But what if it's 20 million amps? The breaker has a limit on how much current you can put on it before it just explodes. And that's the interrupt rating. We do the short circuit calculations to make sure that the calculated short circuit current does not exceed that interrupt rating of the electrical equipment.
And then, Stephen, what is the benefits of a short circuit study?
The short circuit study prevents electrical equipment from catching fire or exploding if there's a short circuit. So because we let the owner know what the available short circuit current is at each piece of electrical equipment, and we, in relation to what its interrupt rating is. So this, this prevents the damage. If the owner matches them correctly, this will prevent the damage to the property and prevent injuries from happening.
Absolutely. Jeff, we're going to go to you for talk a little bit about infrared thermography. Can you explain infrared thermography and how it's used in predictive maintenance, reliability, and safety?
Sure. Thank you, Jared. Very excited to talk about this. And we'll break it down into 2 slides. So infrared thermography, it's a process of using a thermal imager, state of the art, to detect radiation, heat, emanating from an object, converts it into a temperature and displaying a thermal image, also known as a thermogram, of the temperature distribution pattern. So let's back up. What's this all about? There's science, there's physics, there's math. Infrared radiation was actually discovered in 1800 by an astronomer by the name of Sir William Herschel. And he used a simple experiment by dispersing sunlight through a prism, placing a thermometer at the location of each color. So we have the electromagnetic spectrum. You see the graphic down below? You've got different wavelengths of different frequencies, and infrared falls somewhere in the middle. We've got 7 of them from low to high: radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma ray. Well, all objects will emit radiation, right? Anything above absolute zero at minus 459 Fahrenheit will emit, but different substances will emit at different levels. And we have to account for all that. So up above in the science and the physics, you've got epsilon, rho, and the T for transmissivity. Certain objects are going to absorb, reflect, or transmit. And it's important that thermographers and professionals that are doing this have the training to be able to differentiate, because the cameras will, while they are sophisticated, will only provide you with the right accuracy with the right input data loaded. So we move on to our thermal imaging cameras, and we can save all that other science for another course. We'll leave that for the certification agencies. But you've got 2 different types of thermal imagers here on opposite ends of the spectrum. You've got at the top end, your T series thermal imaging cameras shown. They range from $28,000 to $40,000 a piece to this low-cost little spot radiometer, they call it, that you might buy at a local hardware store for $150. Of course, the range of accuracy with these cameras is astronomically different. You're going to end up with spot size and resolution and a whole host of other things. But in simplicity, a thermal imaging camera is made up of a lens, maybe 12 grand, a thermal sensor, a detector, processing electronics, a mechanical housing, an LCD display, and a whole ton of accessories and features right now. And you'll see some cool images, no pun intended, later in the presentation. But basically, the lens will focus your infrared energy onto the sensor. It'll output it to the screen, as you can see, and then through the processing and software, you can produce your imagery and your reports. These cameras that are on the screen, the professional grade ones, typically a 640 by 480 resolution up to 1024 by 768. And the pixel counts are incredible, 307,000 up to 1.228 million, using some of these extra features such as Ultramax. Basically, then you end up with, we can scroll to the next slide, Jared. So what you got here is infrared technology is so useful. It's really going to provide you with all the reliability, predictive, and hopefully proactive in combination with all sorts of other testing and inspection activities, non-destructive. You want to use it in combination with other technologies. It's not a single point, sole exclusive diagnostic tool. What I'm showing here on the graphical display is what's known as the PF curve, the potential failure curve. It's basically just a way of representing an asset's behavior or a condition before it reaches its failure mode. It'll illustrate an asset's progression towards failure. So what we're trying to do is use the technology to try and predict and forecast through temperature measurements potential unusual circumstances, such as imbalanced loads, loose connections, deteriorated connections, overloaded circuits. The graph will really just help display the health of an equipment over time. And with the idea of being, if you wait too long, you get to the protective domain, which is too late. You start hearing mechanical chatter or electrical noise, and you have heat that's to a point of imminent failure. So what can happen here with the infrared services, you've got the ability to check all of your electrical systems for abnormal temperatures. There's a safety aspect to it too. Anybody working on that equipment needs to be safe. So you want that equipment functioning normally. With the age of equipment and other factors, as we mentioned earlier. You got mechanical systems, rotating systems, refractory, boiler, insulation breakdown, machine condition monitoring, liquid levels, tank levels, process flow, sludge, all kinds of different potential applications, building diagnostics, roof systems, leak detection for compressed air systems, and other mechanical applications, so steam traps, for example. And then you got energy savings. It's a whole new world of conservation and sustainability. Of course, we're having audits from ISO 9000 and ISO auditors, EH&S and safety professionals, insurance company loss prevention agencies. So all of these factors come into play that the infrared technology can help you in your total portfolio of your risk.
Great. I know we're probably everybody's probably excited to see some images. Can you share some examples of infrared thermography and the dangers detected?
Yeah, that sounds great. So we got some interesting images here from actual inspections that we've done here, several of which I've done personally. Here we've got a deep well injection pump VFD reactor cabinet. And here in the connection block, we've got a C-phase lug that's over 360 degrees Celsius. Wow, it's a whopper, almost 700 degrees Fahrenheit. Of course, you can see the cable is charred and burned through, and these connections, a high resistance connection is resultant here from a loose, poor, deteriorated component. Down below, this is the spot that I was at. We have mechanical friction happening here on what's known as a pineapple mill roll stand. There are hydraulically operated equipment here, motors at about 100 horsepower, and the center one is the one where on the tail end of it was experiencing mechanical friction, metal on metal contact rubbing. That back plate was either distorted and needed to be reset to allow the boards to come through to get planed and milled. And the other two mill stands didn't have that type of a thermal pattern, that amount of heat on the front or rear side of it. So it was a real big exposure because you have all the right conditions. You've got heat, you've got fuel, you've got atomization potential, and a real exposure for fire.
Great. How about these?
Several others here. I mentioned HRC, or high resistance contact. Basically what we've got here in the world of electrical systems, there are four major categories of electrical breakdown failure. Poor connections with relative to overheating, poor connections, cable insulation breakdown, excessive current loading, and the fourth would be induction heating. So we've got actually up in the upper left, top left, you've got a combination of the two. You have a loose, deteriorated, poor contact surface integrity on that connection. And you actually have induction heating because they put a C-clamp on that thing, and it was of dissimilar metals. So you got two competing metals that can't live in the same space, if you will. So there's a reaction happening there. In the top center, you got a motor starter overload. That contact on that B phase is gone bad and needs to be cleaned up, and possibly needs an aged piece of equipment. So you may have some interior issues going on there, where it might even need need to be replaced, but clean tightening. On the top right, you actually have a normally operating engine block heater. So sometimes we're checking for heat that's supposed to be there to allow for that fuel to be properly heated up so that the engine can start properly. So it's a check. If it's cold in this case, that's a problem, and we're going to identify that. Here on the bottom left, what you have is a high resistance contact and a bad loose deteriorated connection. It's on the C phase of that fuse clip, and we got some big time temperature going on. It's a 600 amp disconnect, serving a 300 horse compressor, supplying plant supplied air. So this is a big downtime if this fails, and it's ready to. In the middle, I've used some software techniques on this. Normally, you're going to use an iron palette for electrical. I've done this for effect for a little bit more visual appearance. I've used what's known as thermal fusion here. You actually see the digital picture because these cameras have the ability to do both thermal and digital. So you've got the two working, overlaying on each other, and you can see the digital picture of the breaker. And this is at a cocoa plant. And the B phase has a deteriorated bad lug connection that's in need of clean tightening. You have on the lower right this circuit disconnect and connection blocks. You got something on the left, A phase, and you also have a splice and a cable that's starting to deteriorate. I believe this one had exterior insulation breakdown, and so you see a spike where the circle is. But just really great findings that come to you real quickly and very readily that you wouldn't know of just by visually looking at it, unless you notice there were deteriorated conditions. You certainly won't know what the temperature is, though. Thank you. Here we just added a little graphic on a high voltage switching equipment, and we had some serious temperatures here. Of course, you've got the roof system above, so if you end up with a failure condition, catastrophic, you run a risk of fire spread, tracking along the bus cable and potentially to surroundings. And if it gets to the roof, you see what Steve was showing you earlier with the fire spread that would be literally catastrophic.
Wow, thank you, Jeff. Those images are really telling. So can you explain what an infrared thermography inspection involves? Like, severity, impact ratings, things like that?
Sure, absolutely. So what I've done here is created, I'm going to have you just cycle through all of them for me, Jared. I appreciate that. I've created a pyramid and just kind of working from the bottom up. That would give you a little bit of a overview. You got to start off with the skilled, qualified, and certified consultant / thermographer / engineer. That's critically important because the technology has to be applied in the correct manner in order for you to have a legit, competent, and qualified survey being done. So there's a professional accreditation, American Society for Non-Destructive Testing, and there are specific examinations that are required in order to get your level 1, 2, or 3 certification. So that's critically important, and somebody that understands electrical and mechanical aspects. So then we proceed to the equipment. We talked about the thermal imaging cameras. The caliber level of your inspection is going to depend heavily on having the right tools and the right level of sophistication on that. So, most of our clients, if they buy the equipment themselves, they may not be in the budget to spend for a T-series camera, professional grade, 640 by 480 or better camera. They may get a very good quality maintenance troubleshooting camera, and it'll do a great job for them. Of course, accuracy will go up and resolution with the level of your equipment. Then, of course, safety is paramount. That's what this whole webinar is about. It's got to be a critical component of this because you're working on the equipment live while energized. It's got to be live, energized, and loaded. So you're going to, count on Steve and the team and the arc flash professionals to providing good safety labels. and that will give us our PPE categories and levels. Of course, the thermal imaging, the work scope is going to be both electrical and mechanical. Our airborne ultrasound is going to be used on strategic high and medium voltage, as well as low voltage assets, where perhaps maybe it's unsafe due to danger levels, and that we can't get a particular cover open. And the use of acoustic airborne ultrasound and or structure borne will be able to listen inside the asset for anomalies indicative of a wide range of things from mechanical to electrical, corona, arcing, tracking, and things of that nature. We have the visual examination piece, and that's going to do all the non-thermal elements, you know, deteriorated bad wiring practices, contaminants, code busting type items, whole slew of other things. We're going to quantify our faults with severity and impact ratings, and you want to use good internationally recognized categories and standards for that. We have a 4-star scale. You're going to go from a 1, which is a minor, 2 to an intermediate, 3 to a serious, and 4 to a critical. And there are temperature thresholds, delta temperature thresholds for each of those categories. And then you're going to assign a combination impact rating to it, high, moderate, and low. And you're going to tag a loss estimate to it. You're going to tag an equipment criticality to it. We also have specialty checkpoints. You know, various customers have various needs. You know, if you're a food and grain industry, or you're a power plant, or you're a mining industry, or cement, you're going to have all kinds of chemical. You're going to have all kinds of hazards, and perhaps some additional checkpoints need to be made on the work scope. We can customize and tailor those, and that should be included in your inspection. The value goes up exponentially. All the while, you want to be using consulting services. After all, we are not inspectors or auditors, we're consultants. So we're providing solutions and risk identifications of hazards. The rubber hits the road with the reporting. With the technology and tablet software, we have the ability to produce very high resolution reports with amazing graphics and root cause, probable cause, recommendations, checkpoints, pinpoint the asset, throw on our severity and impacts. And ultimately then, you know, your company wants to be prepared to quickly mitigate those risks. The only way you get that done is get it out to your maintenance and engineering teams and have them do a local de-energization, complete the repair safely, and then fire the equipment back up, and you're back up and running. Therefore, you're in a controlled mode versus a reactive emergency mode. So that's pretty much an overview of the inspection.
Great, thanks, Jeff. That was really interesting to hear all that about infrared. Stephen, we're going to go back to you quickly to talk about coordination, but I want to remind the audience to put your questions in the Q&A box on your screen. We'll get to them at the end. We want to hear from you, so please keep those questions coming. So, Stephen, what is a coordination study?
Well, in your house, you have a panel board. The panel has a main breaker. Let's say it's 100 amps. And there are branch breakers, say 20 amps, 30 amps. Let's say one of the 20 amp breakers feeds the kitchen receptacles. If your toaster has a short, you expect that 20 amp breaker feeding it to trip. Why doesn't the 100 amp main trip? Because the breakers are what we call coordinated. The breaker closest to the short circuit is the one that you want to trip. Otherwise, you'd lose power to your whole trip. So the 100 amp breaker only trips if the 20 amp breaker fails to trip, or if there's a short in the panel board somewhere ahead of the 20 amp breaker. This example is very simple. It's a very simple one for a house, but in an industrial facility, it's far more complicated. There are multiple panels, multiple voltage levels, multiple sources, such as batteries, generators. It's just much more complicated and a lot more work.
Absolutely. So what are the benefits of doing such a study?
Well, in large industrial facilities, breaker tripping is very common. Without a coordination study, a short circuit on a small branch breaker could take down the whole plant, or at least significant portions of it, or critical equipment. And it wouldn't it would take a lot of time to troubleshoot where the problem was. So let's say you own a large industrial plant. If the coffee maker in the office overheats and trips the breaker, do you want to trip the breaker that just feeds that kitchen circuit, or do you want to trip a breaker upstream and lose millions of dollars a day because the whole plant shut down or critical equipment shut down? If the whole plant shuts down, how do you know which breaker tripped? It's going to take a long time to troubleshoot, each breaker in the plant, and now in terms of life safety, it's usually not a problem. But if you lose power to the fire pump because the coffee maker overheated, making a small fire, there's no fire pump to stop that fire from growing. So it could rage into a very large fire, and you could lose your whole building. And of course, there's also a risk to personal injury as well.
You bet. So let's talk finally about arc flash. What is an arc flash risk assessment?
Well, with a short circuit, two wires touch. But in an arc flash, if you bring the two wires close enough to each other without touching, there's a little lightning bolt that occurs between them. This is an arc. Again, as I mentioned, it's 35,000 degrees. It's hotter than the surface of the sun, and it can throw a grown man across the room, and the heat and the pressure are just really devastating to lives and property. Arc flashes have been around since electricity's been around. They were always considered something of a random event. People didn't know what to do about it, so they just kind of prayed that it didn't happen. But a few decades ago, there were some professors and some other experts who figured out how to model them, how to create a mathematical model for them. And since then, the regulations require that workers be protected from arc flashes. Engineers like me, we create the models and the calculations to determine how much energy can come out of each piece of equipment. When an electrician's working on that equipment while it's live, he could refer to the calculation I write to tell him how much energy that equipment can emanate. And based on this, he'll know what kind of PPE to wear. And
I want to put this on the screen as well. Do you need arc flash labeling? This is very, very high level grid structure that can help you sort of answer that question. Basically, if your facility is in a state that adopted the NFPA 70E from 2017 or more recently, if your equipment is rated 1200 A or higher, if the voltage is 50 volts or higher, you're experiencing a nuisance, circuit breaker tripping, or electrical system components show evidence of burning or arcing, then yeah, you do need to assess that and make sure that your labels are right, and more importantly, make sure that your whole system is right. So I wanted to just put this on the screen so that folks have it if they reference this later. I'm going to go to some final question here that we'll end on this question, everybody. Why is it so important to take a holistic approach to electrical reliability that includes, all three of the studies, right? Coordination, short circuit, arc flash, as well as infrared thermography. Why this holistic approach, and why is this the most important?
Well, the short circuit, coordination, and arc flash, they're all really needed, and the greatest benefit is cost. There's a large cost associated with surveying the site, creating the model, writing each report. It obviously saves you a lot of time if you do all these things once and just add sections for them, rather than make 3 visits, 3 models, 3 reports. It's also better to maintain it if you have one calc in one place, rather than have 3 different calculations that you have to maintain. We use the same software. Every company uses the same software for all 3 calculations. So there's only one model that's created. It's just different scenarios are running. It's easier to have all the information in one place. It's easier to create safety training material when you have a single document to refer to. The arc flash calculation, in a way, is a combination of short circuit and coordination. If during the coordination study you decide that you should change a breaker setting, it'll change your arc flash values. And if a panel is determined to be inadequately sized for a short circuit cut study, it'll need to be replaced, which also affects the coordination and the arc flash study. So it makes sense to do them all at once.
So yeah, I was going to say thank you to our presenters. We're going to take questions in just a minute or two. But just so everyone knows, you have our contact information on the screen, and we're ready to talk about any of this at any time. But yeah, let's go to Q&A. We're excited. First question, let's go to Steve. What are the dangers of not doing short circuit or coordination studies?
Well, the arc flash labels are required by OSHA. So an OSHA audit could lead to fines if you don't have them. But a bigger problem would be the potential fires, injuries, and loss of production. These costs are potentially very large. And if you don't have the calculations to show that you made a good faith attempt to prevent these disasters, your insurance company could reject your claim or just reduce it or give you a hard time with it. Short circuit and coordination are not mandated, but they are recommended. That doesn't mean it's really an option. Think of it as being mandated by common sense. There is no government agency that mandates that I change the oil in my car every 5,000, but I do it because of the cost-benefit analysis of my engine seizing, warrants regular oil changes.
Yeah, absolutely. That's a good analogy there. The oil change in the car. Next one here is for Jeff. Got a question about infrared. What kind of equipment is needed for an infrared thermography study, and is it something we can do ourselves, or is it necessary to partner with a risk engineering firm?
Yeah, thank you, Jared. Basically, what you need for starters is an infrared thermal imager, and there's several things. There's guides out there as to what you should be looking for when you're looking to purchase an infrared imager. Things that are some of the primary features you're going to consider would be the getting the highest image quality and resolution. Of course, the higher the image quality resolution, the temperature range and sensitivity, the larger the cost of your camera is going to be. And there are various specifications and models that'll get you a wider range of temperature on the low and the high end. The sensitivity and the accuracy from 1% to 2%. Consistency in repeatable values, a lot of features that are going to allow you to do a lot of different trending and abilities to put on different spots and make sure that you're using the right aspects that you go through the certifications to actually be able to use it. You might have some additional tools and test measurement instruments, meters, clamp meters for amp, volts, resistance, moisture, for electrical loads. And there may be needs or wants for going with some of the wireless mobile app opportunities, so you can stream it, video, possibly control it from a tablet or a phone. And maybe other additional ergonomic features or functions within the camera that allow you to do digital overlays with a combination infrared and thermal. And then you got all the software aspects of it, which is a whole range of different elements that you have to consider. And there's a lot of training and applications there. You certainly want to get a warranty because of the cost, and tech support from your vendor. But as far as doing it yourself and versus using a professional firm, I always say a combination approach with everything is the best approach. You want to have a comprehensive, uniform, consistent way of doing it. So if it depends on what your program goals are. Is this just one facility, or are you dealing with 400 facilities around the world? And we do everything from just single one-off projects all the way up to clients that will have us do a couple of hundred inspections. So there you run into the single most important thing is uniformity of approach. You got to have good consistent methods on the program. You've got to be able to outline your work scope and what are going to be the major checkpoints in the inspection process. It all starts with having experienced, qualified individuals. Are you just dabbling with this, or are you looking to have an experienced professional that does this every day? You know, a lot of our clients will have an electrician or somebody that will do some spot work, but maybe the camera's sitting on the shelf for 9, 10, 11 months out of the year, and they come out and use it for troubleshooting. That's great. But if you're doing this on a site-wide basis to do a full-blown audit or a survey, you really need somebody that's sophisticated, it's got the certifications, the hours behind the wheel of doing that. You certainly got to have the equipment. You know, if you're just going to have a small lower grade camera that is good for just basic troubleshooting, perhaps you're not going to be able to do the full range starting at the utility services where you need long range and you got to have better resolution. So then you deal with having a range of different safety and training, and that's what this webinar again is all about. So you've got to be able to make sure that your people that are doing the work are properly trained and certified on the 70E side of the house, and making sure that you got that aspect covered. So there's a lot of additional tools that you might consider using in addition to the technologies, but certainly those are the major components and all the hardware software aspects.
Great. Yeah, thanks, Jeff. And I'm going to stay with you, Jeff, on this one. Here's the question. A lot of jurisdictions, Australia, for example, do not allow the use of IR on live equipment, such as electrical switch gears. How can you benefit from IR at those jurisdictions?
Well, interestingly, I do have a team member out there, and we actually do quite a bit of work in Australia. So as is the case in every part of the world, because we are doing it around the entire globe, every facility, whether it's manufacturing or non-manufacturing, commercial, high-rise real estate, can benefit from the technology. Using it for your electrical, for your mechanical, for QC and troubleshooting is going to be a benefit, because you're forecasting these potential abnormal temperatures, these heat patterns that are coming from infrared radiation, based on a condition that's happening as a fault. So I think what you would want to do there is get in touch with that AHJ, that inspector or that agency that's preventing you from using a predictive tool, and finding out what the root cause is. Is it because they're concerned that there's a safety aspect because you have to work on it live and energized, or is it there are some other restrictive elements that are in play? And then maybe if you have a qualified firm, somebody like us or another company that it has a license and bonded, insured, and has a full program, you'd be able to maybe bypass whatever those challenges are, why they're preventing what's widely known in industry as a really great tool for using in a risk and a predictive safety reliability aspect. Hopefully that answers it.
Yeah, absolutely. And then looks like one final question here for Steve. How are today's supply chain problems playing into this? Is it that much more important to ensure electrical safety because of the length of time it takes to get equipment like transformers and other things?
Nope.
I think you're muted, Steve.
I think the loss of production is the most significant cost associated with an electrical equipment failure. I guess lead time wouldn't have too much of an effect on injuries, but the increased lead times for replacing the equipment, when there's a longer lead time, obviously there's more downtime. A critical transformer used to be available, let's just say one was available in 30 days, and now it's not available for 9 months. There's 8 extra months of downtime. The lifetime cost would increase ninefold. So it makes making sure your regular maintenance is more pertinent, because if you're not up to date and you do have an event, it's far more costly.
Great. Thanks so much. Ramesses, we had a question here about, will we provide a copy of the presentation when it's over? I assume we will. That's probably handled on the RIM side. And then, how will we provide certificates of continuing education credits for RIMS? I assume that's all, wrapped up in some post production emails from RIMS. So I don't know if you have anything to add there, but that's all the questions we had on the content side. So thank you everybody for taking time out of your day to spend with us, and we really appreciate it.
All right, that was great. RIMS would like to thank Stephen Wilder, Jeffrey Freilich, and Jared Shelley of Tuve Sud Global Risk Consultants for their time and expertise. A copy of this webinar will be archived on the on-demand events page of rims.org shortly. For more information about Tuve Sud, you can visit tuvsud.com. That's tuvsud.com. Folks, RIMS events are live. Join us at the RIMS ERM Conference 2022 in Indianapolis, Indiana on November 10th and 11th. Visit rims.org/ERM 2022 to register. We want to see you there. Finally, RIMS is global, and we would love for you to build your network with us. Visit rims.org/membership to apply for a RIMS membership. Thank you all, and stay safe.